So I want to start with a tour of some terroir, since I'm going to tell you what I think is the biggest problem with terroir for the Anthropocene. And first off, I have Saint-Emilion. This is one of the famous regions within the Bordeaux wine growing region, which made Cabernet Sauvignon and Merlot arguably very, very famous, and is part of the reason that Napa Valley in turn, which I'll show you, has a very similar climate to Bordeaux, went and planted those same varieties. And these varieties and this terroir is very different than one just a couple hundred kilometers away. Some of you may recognize this as Châteauneuf-du-Pape, which is famous for its galets roulés stones, which suck down the heat of the sun and hold them in the nights. And so this region grows a very different set of varieties, much more late ripening, heat loving, and needing a lot of warmth to ripen varieties. And that's in a big contrast to this region, which you've already seen today at least once. This is the increasingly growing wine growing region of southwest England. This photograph comes from Kent. And this is a region that tends to need to pick varieties for its terroir that can ripen quite quickly. So it has switched recently, as it's warmed, to champagne varieties, which tend to take just a little bit of heat relative to other varieties to ripen. And so people have mentioned to you this concept of terroir, which the French often take credit for, this mystical term that tries to capture all of the environmental attributes that make a wine from a specific region capture that region. So it always includes the climate. It includes the soil, the topology, the topography, and the variety choices of that region. And what I think is the biggest problem today is that we need to accept that the terroir of every wine growing region is changing. So certainly over the several millennia of human winemaking, lots of things haven't changed. The soils are relatively steady over those thousands of years, the geography as well, but the climate has radically changed in the last 40 years. And that means this concept that was really focused on the static idea of a region that has a climate that doesn't change, has changed. In the last 40 years, the terroir of Bordeaux is no longer the same terroir that it was. And it will be a totally different terroir, I would argue, in many ways in 20 years. And let me show you some examples of why we know that. I'm going to visualize climate space here in two axes. So on the vertical axis is the maximum temperature of a region in Celsius, and on the horizontal axis, the growing degree days above 10 degrees C. So the thermal sum, basically, of how warm that growing season is. And I've shown you two different regions that, as I mentioned, grow very similar varieties. This is Napa and Bordeaux, across 30 years, so two-dimensionally trying to capture the climate space of these regions. This is what these regions looked like before significant anthropogenic change. And this is the climate space of these regions today. Europe has warmed in its summer growing season temperatures almost 20% in the last 40 years. This is a dramatic change in the terroir for Bordeaux. A couple other comparisons, two places that grow champagne wine grapes now. You can see we've moved into a much cooler climate if you look at the maximum temperatures and those growing degree days. But you will similarly see that these regions have changed a lot over the last 40 years compared to before significant warming. One last one, famous for Pinot Noir, Burgundy, and the Willamette Valley in Oregon as well. Again, a cooler region in between the last two different sets of figures I showed you, but again, changing very rapidly, especially in Europe. And these two metrics I've shown you, maximum temperatures and growing degree days, are actually, according to my research, the climate metrics that are changing the most by far in most wine growing regions, especially in Europe, which has experienced the biggest shifts to date. Okay, so I want to talk to you very quickly, because we're doing quick talks today, about why variety phenology matters. This is what I think a lot about. I focus on variety change with viticulture in the face of a changing climate, specifically through the lens of thinking about the phenologies, the timing of different varieties, and I'll tell you why I think that matters. I'll tell you quickly that I think there's good evidence that variety change could make big differences in the regions we have in the future and how much we need to turn over currently non-used agricultural land that could potentially be conserved and grow new wine grapes, versus thinking about how to adapt in place, how to change what we have now and not expand wine growing regions so much. And then I've already given you my argument that we really need to think of terroir as something that includes climate change. I'll close very briefly on that. Okay, so to get started, these are the major phenological stages of wine grapes. It starts in the spring with budburst, followed by flowering, and then veraison, which is the rapid uptick of sugar in the fall period or late summer, followed by maturity. So a lot of the phenolic conversations are talking about that period of veraison and maturity, which are quite important. When you select a variety for a region, you have to be very careful to match all these phenological stages to your region's climate. So that's why places like Châteauneuf-du-Pape tend to grow really late ripening, heat-loving varieties, where Champagne needs to grow quick ripening, fast varieties so they can get in their entire growing season. You also need adequate temperatures for flowering to get high yield, and an ideal climate during this veraison to maturity period. You need it to be relatively cool to get high quality grapes. But I would argue that the most important thing when we think about matching phenology of a variety to a region is that we're seeing increasingly with climate change that this really matters to what I call climate hazards. So increasingly how well matched your variety is, I think determines a lot of how much you see these extreme events having a big impact. And just to walk through some examples of that, bud burst determines your frost risk, as someone already alluded to. So the big freezes that we've seen in France in recent years are surprising not because of the low temperatures necessarily, but because all the grapes are actually at a very similar stage of bud burst. And that's why they're at such high risk for low temperatures. Similarly, we're seeing increasing evidence out of the south of France that when you see plants that look like this during the heat extremes we've had in Montpellier and around, it's also the plants that are at flowering. They seem to be at the highest risk when they're going through this flowering stage. These plants obviously have significant damage, but many plants abort the flowers and the growers lose entire yield. And then certainly, as has already been alluded to, the worst time usually to have a smoke event is to have it during veraison. The grapes are really starting to expand and take up more and more of what is in the environment around them. So if you have a smoke event that happens during veraison, that is usually one of the worst timings for it. And increasingly, as everyone has mentioned, we are pushing our harvests earlier and earlier. This is great data out of a common garden of Rhone varietals in the Rhone region of France. And what you can see, hopefully here, if you look at the decades, is that we're not just shifting the curve as we've shifted warming earlier, we're shifting the shape of the curve. And that's why people are really worried about phenolics and tannins, because we've moved it up, we're getting different sugar to acid ratios, we're getting a totally different development of wine grapes. And that's a big problem for quality. So I think phenology is really critical because it doesn't just determine how does it match the climate on a mean basis, but it actually determines the climate hazards that these regions are experiencing. We don't really have good metrics to try to figure out how to match them that well, I would argue. Okay, but we do have some evidence that variety diversity really does matter to buffering regions from climate change. And I'll show you a project I worked on with a series of international collaborators, but especially these two guys. This is Ignacio Morales Castilla, who is now at the Universidad de Alcalá, who led the work in my lab, and Inaki Garcia de Cortazar, who also worked on it as well, along with Thierry Lecombe and some other wonderful collaborators. And what we did is we built sophisticated phenological models. We built bud burst to flowering to veraison, and then a niche model for maturity. And we said, where could you grow wine grapes if you just thought about the phenology from our models? And this is what we ended up with, these regions of wine growing. This is before significant anthropogenic climate change, and we projected them forward to 2 and 4 degrees of warming, which I'll show you quickly now. So here are the regions before, and as you can see with warming, we move significantly poleward in most regions. But what was interesting about this project is that we tried to measure and model the varieties separately. We had 12 varieties where we had enough data to do this, and then we could ask what happens if instead of what we usually assume as researchers will happen with climate change, that growers change nothing, that they are static and don't change their management in any way. They just move where they plant grapes. What happens if they actually change their variety, which is only one of the things they could do, but is a major change for sure. And what we found was that if growers change their varieties, it more than halves the loss of wine-growing regions that people have been projecting now for 10 or 20 years. So I would argue that's excellent evidence that varieties really matter, and thinking about variety change matters. And I want to point out that this is a limited amount of the diversity that we have. So this map tries to show all the varieties that are planted today with data from 2010, I believe. Each dot or circle is a different wine-growing region, and the size of that circle tells you how many varieties that region plants. So you'll see lots of New World regions plant 40 to 50 varieties or even more. But the color of the circle is also important. So the color of the circle here represents 12 varieties that are so commonly planted, and many of which we modeled because they're the varieties where we can actually get data, are called international varieties. You probably recognize a lot of these names: Cabernet Sauvignon, Chardonnay, Pinot Syrah, Sauvignon Blanc, Riesling, Gewurz, Viognier, Pinot Blanc, and Pinot Gris. These are the varieties that cover most of the world's wine-growing regions. So the color of those circles tells you the percentage of hectares that are in these different regions. So places like California, Australia, especially new growing regions in China. They might be planting 10, 20, or 50 varieties, but 80% of more of their hectares will also often be international varieties. And in many regions, it's only 3 or 4 varieties that are making up this 80%. So where is the diversity? Well, as somebody has already mentioned, it is locked in the Old World. So this is just a close-up of that map for the Old World wine-growing regions. And you can hopefully see a few things here. One, the circles are big. Italy, Portugal plant hundreds of varieties in extremely tiny regions. And almost none of those varieties are international varieties. What does that mean? Well, one, it means that in Europe, there's actually usually a better matching of variety phenology to the local climate. So they work harder to match bud burst to maturity to varaison to their climates. It also means that very little of this diversity has ever made it out. So of the 1,100 varieties that are planted today, only 300-ish have ever made it into New World wine-growing regions and been planted today. And furthermore, our model that I just showed you only includes 1% of them. So a minuscule amount is what we could work with in our paper, because we have so little data on most of these varieties, which I think is a big problem. And the other thing I want to stress here about what's happening in the Old World, as some has mentioned, there is a lot of variety diversity, and I would argue there's also a lot of interest in thinking about how to change varieties, even if the legal restrictions are harder. So Bordeaux, for example, has had for over 15 years the VitaDAP project, it might be 20 years now, where they've looked at over 50 different varieties that they might consider changing to. And they're actively working on and thinking about what to do with climate change. So my argument for how we have to think about terroir today is we have to admit that with climate change, we don't have the terroir of Burgundy and Bordeaux of the 1970s or the 1960s. We have a new terroir for these regions, and we'll continue to have a new terroir for all of these regions. So I would argue that we should incorporate climate change as an aspect of terroir on 2 axes. The first one is, how is the climate change happening in that region? What we often call climate velocity. How fast, how much, in which directions of drought, temperature, precipitation, et cetera. And also, what are regions doing about it? Because I think climate change is obviously something that is happening to regions, but how well they're adapting and how they're choosing to stay in place or change where they grow grapes is something else that I think we should consider for terroir in the future. With that, thank you all.